In this session, we are going to discuss trigonometry, and the concept in trigonometry that we are going to give attention is called the angles in the Cartesian plane. Angles in the Cartesian plane. Let me draw a Cartesian plane. A Cartesian plane is basically the set of axes. Y-axis and the x-axis. This is a Cartesian plane. And we know here we've got the origin. At the origin, x is 0, y is 0. And a Cartesian plane is divided into 4 quadrants. This is quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. Remember, in mathematics, when we measure angles, we start from the positive x-axis, and then we measure the angles anti-clockwise. So this angle here, we start here, it's 0. We've got 90 degrees there on this line. On this line here, we've got 180 degrees. On this line here, we've got 270 degrees. And then back a revolution, 360 degrees. This is a Cartesian plane divided into 4 quadrants. All the angles in the first quadrant, they are the angles between 0 and 90. Angles in the second quadrant, they are between 90 and 180. Angles in the third quadrant, their sizes varies from 180 to 270, and the angles in the fourth quadrant are between 270 degrees and 360 degrees. This is a Cartesian plane, and in this Cartesian planes, we've got angles in different quadrants. Thank you. Let's check. According to, if we can just to try and simplify this section that I want to do with you right now. If you take first quadrant, this is the first quadrant. All the angles are between 0 and 90. And if you check the trig ratios I'm referring to sine, cos, and tan, including their reciprocal identities. Remember, the reciprocal of sine is cosec, the reciprocal of cos is secant, and the reciprocal of tangent is cotangent. So these trig functions, including their reciprocals, we want to check their size in the different quadrants. If you can use a calculator, any angle between 0 and 90 is in the first quadrant. And if you check the sine, the cos, and the tangent thereof, you will find that it always yields positive answers. So in the first quadrant, all trig ratios are positive. For example, any angle, let me take 30 degrees. The sine of 30 degrees will be positive. The cosine of 30 degrees is positive. The tangent of 30 degrees will also be positive. So that is applicable to all the angles between 0 and 90, because angles between 0 and 90 are in the first quadrant. And in the first quadrant, all trig ratios are positive. If we go to the second quadrant, the angles in the second quadrant, they range between 90 and 180. They range between 90 and 180. And if you check their trig ratios, let me say, for example, 150, you take the sine of 150. If you take the sine of 150, you'll find that it's positive. But if you get the cos of 150, you take the tangent of 150, the two will yield negatives. So in the second quadrant, all the trig ratios are negative except for sine. Sine is the only trig ratio that is positive in the third quadrant. If we take the very same principle, apply it in the third quadrant, you'll find out that tangent is the only trig ratio that will yield positive ratios. The other trig ratios, they will yield negative answers. The tangent of, if I were to make an example, any angle between 180 and 270, let me take 240 degrees. The tangent of 240 will definitely be positive. The answer will be positive. But the tangent, the cos of 240, the sine of 240 degrees, definitely they will yield negative answers. So in the CAS diagram, according to this diagram, in the third quadrant, only tangent will yield positive ratios in the third quadrant. The other trig ratios, sine and cos, will yield negative values. Check the fourth quadrant. Apply the same principle. Remember, in the fourth quadrant, the angles are greater than 270 but less than 360. So cos will yield positive results. The tangent of any angle in the fourth quadrant, the tangent thereof will be negative. What does that mean? Make an example, 300 degrees, because angles in the fourth quadrant are greater than 270 but less than 360. So take 300 degrees. The sine of 360 will give you a negative answer. The sine of 300 will give you a negative answer. The cosine of 300 will give you a positive answer. The tangent of 300 will give you a negative answer. So all the trig ratios in this one yield negative except for cosine. So this diagram here, we call it the CAS diagram. In the first quadrant, I said all trig ratios, they will give positive values. So basically, all trig ratios are positive here. Can I use the letter A? Allow me to use the letter A. So all trig ratios are positive. In the second quadrant, sine is positive. The other trig ratios are negative. In the third quadrant, tangent is positive. The other two trig ratios, sine and cos, will be negative. In the fourth quadrant, only cos is positive, but tangent and sine will be negative. So this diagram, in short, is called CAS diagram. Cos for sine, A for all, S for sine, T for tangent. This is called the CAS diagram. What is the role of the CAS diagram? CAS diagram indicates the positive. It indicates positive ratios, trig ratios. CAS diagram indicates positive trig ratios. What do I mean by that? Check. In the first quadrant, all trig ratios are positive. So A shows that all trig ratios are positive. I want to emphasize on the positive trig ratios. In the second quadrant, what does CAS show? It shows us S, and S stands for sine. So sine is positive. Tangent is positive. Cos is positive as we move in each quadrant. So all what is indicated here is positive trig ratios. What is not, you see in the second quadrant, for example, you don't see tangent. You don't see cos in the second quadrant. Tangent and cos are not there. They are not indicated because those that are not indicated are negative. Third quadrant, there is no cos, there is no sine. It means cos and sine are negative in the third quadrant. In the fourth quadrant, there is no sine, there is no tangent. It means sine and tangent are negative in the fourth quadrant. What's indicated here are the positive trig ratios. So, grade 10 learners, it's important for us to know CAS diagram, because the role of CAS diagram is to indicate to us in a particular quadrant what is the sign of a particular trig ratio. So we are going to talk about the angles in the Cartesian plane. Angles, they will be in the first, second, third, and fourth. So we need to know the ratios thereof, if those ratios will be negative or positive. I've tried to explain you the CAS diagram. That is how the CAS diagram operates. Allow me to show you an activity here. And in this activity, it's a very simple activity. I want you to identify the quadrant. The activity reads, in which quadrant? In which quadrant does the terminal Sorry. In which quadrant does the terminal arm of the angle lie? We need to identify a quadrant. Let me start with the first one. In the first one, we say sine theta is greater than 0 and the cosine of theta is less than 0. So the question is, in which quadrant does the terminal arm of the angle lie? In which quadrant should we have that terminal arm? This is how we go about in identifying a quadrant. Look at sine theta greater than 0. Greater than 0, once we see greater than 0, we know we talk of the positive ratios. Because any number greater than 0 is positive. If we talk of less than 0, any number less than 0 is negative. So I want to identify which quadrant are we referring to here. In which terminal arm does the quadrant lie? Thank you. Check. Sine theta less than 0. I said to you, less than 0 means, greater than 0 means positive. You go to your CAS diagram. Where is sine positive? So in the first quadrant, all three ratios are positive. So it means here you talk of the first quadrant. Sine, all three ratios are positive in the first quadrant. So sine will be positive in the first quadrant. In the second quadrant, sine is also positive. So it's the first and second quadrant. Sine theta greater than 0 is first and second quadrant. The terminal arm may either be in the first or second quadrant. Here is the CAS diagram. First quadrant, all three ratios are positive. Second quadrant, sine theta is positive. But in the third quadrant, sine is negative. In the fourth quadrant, sine is negative. So the only two quadrants where sine is positive is first and second, as I've indicated here, first and second. Now we need to go to this one, cos theta less than 0. We want to identify the quadrant in which cos is negative. Let's go to those quadrants. Cos is less than 0. Less than 0 means negative. Remember, in the first quadrant, cos is there, it's positive. All three ratios are positive. In the fourth quadrant, cos is positive. But in the second and third, there is no cos. So cos is negative in the second and the third quadrant. Here we're talking about the second and the third quadrant. After establishing the quadrants, you need to look for a common quadrant, because a common quadrant will be the quadrant in which the terminal arm of an angle will lie. Let's check. We've got quadrant 1 and 2. Here we've got quadrant 2 and 3. Which quadrant is common? So the general answer will be the second quadrant, because we have 2 here. Even this one gives us 2. So the common quadrant in which the terminal arm will lie will be the second quadrant. It will be the second quadrant. Meaning, if we were to draw a right angle triangle, we will draw a right angle triangle in the second quadrant. How did you identify it? Sine theta greater than 0, in which quadrant? First and second. Cos theta less than 0, in which quadrant? Second and third. So second quadrant is common. Now we conclude that the terminal arm will lie in the second quadrant. Let me take you through another example. For interest sake, let's take this example where tan theta is greater than 0 and cos theta less than 0, and the cosine of theta is less than 0. In which terminal arm of an angle will those ratios lie? Let's start. Tangent greater than 0, meaning that tangent is positive. In which quadrant is tangent positive? Come to the CAS diagram. All three ratios are positive in the first quadrant. Tangent is positive in the third quadrant. So it means in this case here, we are referring to first and third quadrant. According to cast diagram, tangent is positive in the first and third quadrant. Check the cos of theta. We say the cosine of theta is less than 0. Cos is negative. It means in the first and fourth, cos is positive. Therefore, cos will be negative in the second and third. So this one here will be second and third. Now, to come to a conclusion, look for a common quadrant. Which quadrant is common? We have the third quadrant here. We've got the third quadrant. Therefore, the answer will be in this situation, in this condition, the quadrant referred to today is the third quadrant. Our terminal arm will lie in the third quadrant because this inequality here represented the first and the third. This inequality here represents the second and third. So the common one is the third quadrant. As a grade 10, you should be able to identify the quadrant in which the terminal arm of the angle lies. And this is, I did 2 examples where I would try to show you how to identify a quadrant. Maybe I should take you through the last one. Check this one. Check this one. Sin theta less than 0 and theta should range from 90 degrees up to 270 degrees. All we have to do, we want to identify which quadrant are we exactly referring to in this case. Sin theta less than 0. Remember, sine, you look at the cast diagram, sine is positive in the first and third. First and third, sine is positive. So in the third and fourth, sine is negative. So here we are referring to third and fourth quadrant, because in the third quadrant there is no sine, meaning sine is negative. In the fourth quadrant there is no sine, meaning that sine is negative. So where sine is less than 0, it will be in the third and fourth quadrant. We have this interval notation. What does it represent? You start from 90 degrees to 270. Remember, we've got 0 degrees here. Here is 90, 18, 270. I said at the beginning of the lesson, when you measure angles in mathematics, all the positive angles are measured in an anti-clockwise direction. So you start from 90 to 270 in an anti-clockwise. Here is 90. From 90 to 270. This is 270. So from 90 to 270, you go through second and third quadrant. So this interval here represents second and third quadrant, because you start from 90 in an anti-clockwise direction to 270. The quadrant referred to there second and third. Now you study the situation. Which quadrant is common? You've got third and fourth quadrant, you've got second and third quadrant. Now you draw a conclusion. The common quadrant here will be the third quadrant, because we've got the third quadrant, we've got the third quadrant there. The exercise was just about identifying a quadrant, because once we have identified a quadrant, in that quadrant we are going to draw a right-angled triangle in the standard position. We are going to draw a right-angled triangle in the standard position. Thank you. Here is a question. It reads, if the cosine of theta is cos of 4/5, remember by definition, cos is defined as the opposite, the adjacent over hypotenuse, x over r. And theta must be between 0 and 90. You remember in the Cartesian plane, is between 0 and 90, we are referring to the angles in the first quadrant. Then the question reads, calculate without the use of a calculator the value of tan square theta, cosec theta multiplied by sin theta, cos square theta by sec theta. If they say without using calculator, it means we need to draw a right-angled triangle. So the question is, in which quadrant are we going to draw a right-angled triangle? This interval here, cos theta is equal to 4/5. This ratio itself, 4/5, is a positive ratio. So it means cos is positive in the first and fourth quadrant, still remember the cast diagram. According to cast diagram, cosine will be positive in the first and fourth quadrant. Why do I choose positive? Because this ratio here that is given is positive. So it's either we draw a right-angled triangle in the first or fourth quadrant. Let's read it further. Check the interval notation here. They say theta must range from 0 to 90. From 0 to 90, basically, we are referring to the first quadrant. Now, take the two situations into consideration. The common quadrant there will be the first quadrant. Then what do? You draw a right-angled triangle in the first quadrant. Cartesian plane, X, Y, a right-angled triangle in the standard position in the first quadrant. So our angle here will be theta. Now we have theta in that case. Remember, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So with respect to theta, the adjacent side will be this one. The hypotenuse is this one. There's one side that we haven't calculated, that we do not know. It is this vertical side. Remember, the horizontal one, these are the x values, the vertical, the y values, and this one, the slanting one, will then represent the hypotenuse. So if you have a situation like this, we need to calculate the length of the third side. And to do that, we use Pythagoras theorem, which states r squared is equals to x squared plus y squared. That is Pythagoras theorem. The square on the hypotenuse is equals to the sum of squares of the other two sides. That is Pythagoras theorem. So our hypotenuse is 5 here. You square it. The adjacent side, which is x, is 4. You square it plus y squared. We need to work out the size of y. If you square here, you've got 25. If you square this one, you've got 16 plus y squared. Now, y squared, you group numbers to one side. This 16 must be transposed to the left. 25 minus 16 will give you 9. Now you determine the square root both sides. Therefore, you'll find that therefore y will be equals to 3, because it represents the length of a side. The answer will always be positive. So here we have 3. Now, a right angle triangle, all the sides are calculated. We can answer these questions then. Let's answer the first question. 1.1 tan squared theta. This was the question, tan squared theta. So here we go. Tangent. Tangent is defined as opposite over adjacent. With respect to theta, opposite side is 3, adjacent is 4. Opposite over adjacent is 3 over 4. But because the tangent is squared there, we need to square this ratio as well. So our answer here, if you square 3, you square, you'll get 9. 4, you square, you've got 16. This is the answer that we are looking for. That's the answer for 1.1. Let's check 1.2. 1.2, the question wanted us to work the cosec of theta, the sine of theta. The cosec of theta multiplied by the sine of theta. Let's carry on. Look at the cosec. Remember, cosec is defined as hypotenuse over opposite. That is the definition of cosec. Hypotenuse over opposite. Look at this diagram. Hypotenuse is 5, opposite is 3. You have 5 over 3. You multiply by sine theta. Sine, remember, by definition, sine is defined as opposite over hypotenuse. So opposite here, with respect to theta, the opposite side is 3, the hypotenuse is 5. It's 3 over 5. And if you multiply the two, you've got your answer as 1. That's why they are called reciprocal identities, because reciprocal means when you multiply the two, the product should give you 1. Hence, it's 5 over 3 multiplied by 3 over 5, they will give us 1 as an answer. So those are the reciprocal identities. Check 1.3. In 1.3, we're required to calculate the cos squared theta multiplied by the secant of theta. Cos squared theta. Thank you. Check. This one is a bit easier because already from the statement, you are given cos theta as 4 over 5. Or even if you can look at the diagram here is theta. Cos is adjacent over hypotenuse. It's 4 over 5. This cos is squared. Because it's squared, we need to square this one. Multiply by the secant of theta. By definition, secant is defined as hypotenuse over adjacent. Hypotenuse over adjacent. So secant will be hypotenuse over adjacent. Now, if you multiply, I'm sure this 5 will cancel 1 5 here, this 4 will cancel 1 there, so you'll be left with your answer as 4 over 5. That's the answer that we have ultimately, because it's 4 squared. 2 4s here, 1 4 will cancel this one. 2 5s here, 1 5 will cancel this one. So numerator will be left with 4, denominator will be left with 5. And this will be the answer to this question. These are called identities involving Pythagoras theorem, and they include the most critical thing about this type of questions is for a learner to identify a quadrant in which to draw a right-angled triangle. And remember the process of identifying a quadrant. More often, there'll always be 2 scenarios. The scenario that I showed you earlier, we identified quadrants using the inequality. Tangent greater than 0, tangent less than 0. So of utmost importance is the CAS diagram. Grade 10 learners must understand or must know the CAS diagram. Once you know the CAS diagram, every time you are presented with 2 scenarios, you'll be able to put the 2 scenarios together, and from the 2 scenarios, identify one common quadrant in which to draw a right-angled triangle. Once a right-angled triangle is drawn, 2 sides will be given. You'll be left with one side. So the remaining side that we need to calculate, use Pythagoras theorem. After using Pythagoras theorem, now you have all the 3 sides. You can determine the ratio of any trig ratio. This trig ratio becomes easy to work out, because here is a diagram complete. What is the tangent? Tangent is opposite over adjacent, 3 over 4. Because it is squared, we square it like I did in the example. Got the cosec. Cosec by definition is hypotenuse over opposite. Hypotenuse is 5, opposite is 3. Sine is opposite over hypotenuse, 3 over 5, like I indicated here. So you multiply the 2, the product is 1. That's why the 2 are referred to as the reciprocal identity, meaning even cos and secant, if you multiply the 2, you'll always get an answer as 1. Even tangent and cotangent, because they are the reciprocal identities, they'll always give you a product of 1. So the last one, we had cos squared and sec theta. Cos, remember, by definition, adjacent over hypotenuse. Secant, hypotenuse over adjacent. This is what we did here. And when we simplify the 2, we end up with the answer as 4 over 5. So these are called identities involving Pythagoras theorem. Grade 10 learners, I hope this session will help you to prepare for the end of the exam. Trigonometry is one section in mathematics that carries lots and lots of marks. From grade 10 up to grade 11, even up to grade 12. Trig is the topic that carries more weight. So it's important that we practice and we prepare ourselves thoroughly on trigonometry so that at the end of the year, we can get good marks. On that note, I thank you.